The answer to whether you are allowed by code to wire not Teflon coated class 2 cable without an enclosure within a return air plenum is no. Electrical codes have specific requirements for wiring within return air plenums to prevent the spread of fire and smoke. Return air plenums are spaces used for environmental air, which makes the selection of wiring methods and materials critical. Firstly, it is essential to understand what constitutes a return air plenum. A return air plenum is a space used for the return of air in a heating, ventilation, and air conditioning (HVAC) system. These spaces can include areas above suspended ceilings or under raised floors. Because these plenums can distribute air throughout a building, any materials within them must meet stringent fire safety standards. Secondly, the National Electrical Code (NEC) addresses wiring methods in plenums in Section 300.22. This section specifies that only certain types of wiring and equipment are permitted in these spaces. The general requirement is that wiring must have adequate fire-resistant and low smoke-producing characteristics. This is to minimize the risk of fire propagation and toxic smoke generation, which can be life-threatening. Thirdly, Class 2 cables, while suitable for low-voltage applications, must still comply with plenum wiring requirements if installed in a plenum space. Teflon-coated cables, depending on their specific listing, may or may not be suitable for plenum use. Cables intended for plenum use are typically marked with a designation such as CMP, which indicates that they meet the necessary fire resistance and low smoke producing standards. Fourthly, wire nuts, which are commonly used for making electrical connections, are not typically permitted for use in plenum spaces without additional protection. This is because the plastic housing of standard wire nuts may not meet the fire resistance and low smoke producing requirements for plenum installations. To use wire nuts in a plenum, they must be enclosed in a fire-rated junction box or enclosure that is specifically listed for plenum use. This enclosure helps to contain any fire that may originate from a faulty connection and prevents the spread of smoke. Fifthly, the use of enclosures in plenum spaces is crucial for maintaining fire safety. Enclosures must be made of materials that can withstand high temperatures and prevent the passage of flames and smoke. These enclosures are typically made of metal or other fire-resistant materials and are designed to completely encase the electrical connections. Sixthly, specific cable types are designed for plenum use and are clearly marked to indicate their suitability. These plenum-rated cables are constructed with materials that have low smoke and flame characteristics, ensuring that they will not contribute to the spread of fire or the generation of toxic smoke. Using the correct type of cable is essential for compliance with electrical codes and for ensuring the safety of building occupants. Seventhly, when working with electrical systems in plenums, it is always necessary to consult the local electrical codes and regulations. Local codes may have additional requirements or restrictions beyond those specified in the NEC. It is also advisable to consult with a qualified electrical inspector or engineer to ensure that the installation meets all applicable requirements. Eighthly, the consequences of non-compliance with plenum wiring requirements can be significant. In the event of a fire, non-compliant wiring can contribute to the rapid spread of flames and smoke, endangering lives and property. Additionally, failure to comply with electrical codes can result in fines, penalties, and legal liabilities. Ninthly, alternative methods for making electrical connections in plenums include the use of plenum-rated connectors and terminal blocks. These connectors are designed to meet the same fire resistance and low smoke producing standards as plenum-rated cables, ensuring a safe and compliant installation. These connectors often feature metal housings or other fire-resistant materials and are designed to provide a secure and reliable electrical connection. Tenthly, proper labeling and documentation of electrical installations in plenums are essential for future maintenance and inspections. All cables, connectors, and enclosures should be clearly labeled to indicate their type, voltage rating, and intended use. This information helps to ensure that future work on the electrical system is performed safely and in accordance with applicable codes and standards. In summary, while Teflon-coated Class 2 cable may have certain beneficial properties, it is not automatically approved for use with wire nuts without an enclosure in a return air plenum. Compliance with electrical codes, specifically Section 300.22 of the NEC, requires the use of plenum-rated materials and appropriate enclosures to prevent the spread of fire and smoke. Always consult the latest edition of the NEC and local codes, and seek guidance from qualified professionals to ensure a safe and compliant installation. Remember that the primary goal is to protect building occupants and prevent property damage by adhering to the highest standards of electrical safety. The specific requirements for wiring in plenums are designed to achieve this goal. Consider the broader implications of using unapproved materials. The risk extends beyond immediate code violations and delves into potential safety hazards. If a fire were to break out, the materials used could significantly impact the severity and spread of the fire, directly affecting the safety of the building's occupants. Also, the type of Teflon coating on the Class 2 cable is relevant. While Teflon itself is known for its high heat resistance, the overall cable assembly must meet specific plenum ratings to ensure it does not contribute to smoke or flame spread. The listing and labeling of the cable are critical indicators of its suitability for plenum use. Always check for markings such as CMP, which signify compliance with plenum requirements. In addition to the NEC, other standards and regulations may apply depending on the specific location and application. Local building codes, fire codes, and insurance requirements can all influence the selection and installation of wiring methods in plenums. It is important to be aware of these additional requirements and to ensure that the installation complies with all applicable regulations. The proper installation of electrical systems in plenums is not just a matter of compliance, it is a fundamental aspect of building safety. Taking the time to understand and adhere to the relevant codes and standards can prevent potentially catastrophic consequences. Always prioritize safety and seek expert guidance when working with electrical systems in critical environments such as return air plenums. In detail, the NEC Section 300.22c specifically addresses wiring in ducts, plenums, and other environmental airspaces. It outlines the types of wiring methods that are permitted, as well as the conditions under which they can be installed. According to 300.22 current, wiring methods permitted in spaces used for environmental air include only totally enclosed, non-ventilated insulated busway, electrical metallic tubing, flexible metallic tubing, intermediate metal conduit, rigid metal conduit, or cable trays. Correspondingly, associated fitting and boxes must be attached to the surface of the building structure. Flexible metal conduit and electrical metallic tubing are permitted in lengths not exceeding 6 feet to connect physically adjustable equipment and devices. The cables must be listed as having adequate fire-resistant and low smoke-producing characteristics suitable for the purpose. For example, Type CL2P or CNP cables are acceptable for Class 2 circuits. It is also important to understand the definitions of different cable types as defined in the NEC. Type CL2 cable is General Purpose Class 2 cable. Type CL2P cable is Class 2 plenum cable, and Type CMP cable is Communications plenum cable. These cables are designed and tested to meet specific fire safety standards for use in plenum spaces. Additionally, the NEC defines what constitutes a Class 2 circuit. According to Article 725, a Class 2 circuit is a low-energy circuit with specific voltage and current limitations. These circuits are often used for control, signaling, and communication applications. While Class 2 circuits are inherently safer than higher-voltage circuits, they must still comply with plenum wiring requirements when installed in plenum spaces. The type of insulation on the conductors is also an important consideration. Traditional PVC insulation, for example, is not suitable for plenum use because it produces significant smoke and toxic fumes when burned. Plenum-rated cables use insulation materials such as Teflon or fluorinated ethylene propylene (FEP), which have low smoke and flame characteristics. These materials help to minimize the risk of fire propagation and toxic smoke generation in the event of a fire. The use of wire nuts in plenum spaces is generally discouraged unless they are enclosed in a fire-rated enclosure. Wire nuts are designed to provide a secure and reliable electrical connection, but the plastic housing of standard wire nuts may not meet the fire safety requirements for plenum installations. If wire nuts are used, they must be installed inside a junction box or enclosure that is specifically listed for plenum use. The enclosure must be made of metal or other fire-resistant material and must be designed to completely contain any fire that may originate from a faulty connection. Furthermore, the selection of appropriate wiring methods and materials for plenum installations is not just a matter of code compliance, it is also a matter of professional responsibility. Electrical contractors and installers have a duty to ensure that their work meets the highest standards of safety and quality. This includes staying up to date on the latest codes and regulations and using only approved materials and methods. In addition to the NEC, other industry standards and best practices can provide valuable guidance on plenum wiring. Organizations such as the National Fire Protection Association, NFPA, and the Institute of Electrical and Electronics Engineers, IEE, publish standards and guidelines that address various aspects of electrical safety. Consulting these resources can help ensure that the installation meets or exceeds industry best practices. Ultimately, the goal of plenum wiring regulations is to protect building occupants from the hazards of fire and smoke. By using approved materials and methods, and by adhering to the relevant codes and standards, electrical contractors and installers can help create a safer environment for everyone. Remember that safety is always the top priority when working with electrical systems, especially in critical environments such as return air plenums. In review, the NEC and other relevant standards provide clear guidelines on the types of wiring methods and materials that are permitted in plenum spaces. While Teflon-coated Class 2 cable may have certain beneficial properties, it is not automatically approved for use with wire nuts without an enclosure in a return air plenum. Compliance with electrical codes requires the use of plenum-rated materials and appropriate enclosures to prevent the spread of fire and smoke. Always consult the latest edition of the NEC and local codes, and seek guidance from qualified professionals to ensure a safe and compliant installation.